Okay, my screen is showing, right? Okay, so let me open my VMware and go straight to Kali. So I'm launching my Kali. I believe you can see my Kali launching, right? Please, once again, I'm very sorry for starting late. Uh, this was not planned. I had a meeting and it took longer than I planned to. I thought it was just going to be something brief, but the meeting took longer. So sorry for keeping you there. My Kali is still trying to load, so it takes some time. So far we have been talking about networking. I already explained to you some basic network concept like the IP address, the MAC address, and port. So I just want the Kali to open, then we'll explain one or two things. Whew, finally. Okay, so My Kali is up. I believe you can all see my Kali, though it's still kind of booting, but to some extent it's up and it should be functioning. Okay, so it can already, you can see the signal reading already. Okay. So before we go back to, I think last week we were trying to look at Nmap, how to analyze packet with Nmap before that update came up. So before we look at Nmap, let's quickly look at something we call ping and traceroute. Okay, ping and traceroute. Like I explained last week, this is just the interface of your Kali. This is just the interface of your Kali. Just like Windows, this is also the way Kali is. When you open your Kali, this is like the desktop environment of your Kali. Okay, so on your Windows, normally they are like we have like follow-com folders. Okay, follow-com folders, or let's say directories in your Windows, such as the download. We have the music folder. We have videos. We have folders for documents. We have your desktop and all of that. These are like follow-com directories on your system. That's on Windows. Okay. The same way you have those directories on your Windows, that's the same way we have those folders and directories here on your Kali. Okay. So this very environment is the desktop environment. Please, can you all still hear me? I just dropped a message on the chat. If you can hear me, please confirm. So that okay. So Hyson can hear me fine. Let's carry on. So this is like your desktop environment as well. Okay, and if you can check, you see some folders and maybe some files, right? Then this icon here is just like your start menu on Windows, okay, where you click to open your applications. On Kali, it is up, that's top left, right? So this is where you have applications. Okay, so these applications are categorized based on their functions. Okay, so we have applications for information gathering. If you want anything else to do, cybersecurity is classified into different categories, like in cybersecurity, your first step that you take is called reconnaissance. That's what we call information gathering. Okay, it's just like the police. When the police are trying to do an investigation, the first thing they do is to gather information. They carry information gathering about the particular suspect or a particular person they want to investigate. Okay, so our first set of applications are what we call information gathering. That's where you have all this DNS analysis, IDS, IPS. I believe you know what IDS means. That's intrusion dictation system and intrusion prevention system. We have live host identification network and port scanners, OSINT analysis. We're going to look at some of these things. Then the second set of applications that we're having are vulnerability analysis. Okay, so you use this to check like how vulnerable a particular host or a system is, if that is the person, like if that's the subject you are working on. Then we have web application analysis, database, password attacks, wireless attacks, reverse engineering, exploitation, sniffing, post exploitation, forensics. Then we're reporting tools. When you have gotten to the stage where you need to now write your report, but because for every cyber security, for every like investigation or any analysis you do, you have to get a report at the end of the day. If not, it will just be a waste of time. You have to write like a report for maybe somebody that will be coming later to come and check, or for someone else that want to work on the same case. You understand? So these are where you get your tools. Okay. So what we were working on for today is this terminal, right? So in computer, in computer, we have different ways of displaying data. Okay. In computer, we have different ways of displaying data. So it can either be you can either display data using what we call the graphical user interface, that's GUI, or you display your data using the CLI, which is otherwise known as the command line interface. Okay, I will come again. In computer, we have two ways. Okay, there are two types of interface when it comes to interacting with your computer. So you can either interact with your computer through the graphical user interface, or through, that is the GUI, or through the command line interface. Okay, so in Kali, when you're using Kali Likeness, mostly you interact with applications here through the command line interface. Meanwhile, on your Windows, you will mostly be interacting with your applications using the graphical user interface. I hope we understand. Okay. So for Kali, we interact with most of our applications using the command line interface, that's CLI. Okay. So like I said, there are two ways of interacting with your computer, either through the graphical user interface or the command line interface. So I just launched the Kali. No, I say Kali. I just launched the command line interface. Okay, let me close this and do that again. Just come here. Okay, so if you look up here, you see this application. This one called Terminal Emulator. That's our command line interface. Or if you don't see it, they just type terminal and it will come up. Okay, so you double click on it and wait for it to launch. Okay, so this is my terminal. I believe we can all see it. Okay, so let me try and adjust this in such a way that it will be visible enough. Okay, so this is what we call the terminal. Okay, this is what we call the terminal. Like I was saying, this night I want us to talk about what we call the ping and trace route. Okay, ping and trace route. Let me type that in the Let me type that on the chat so that you can know what, because I might not be pronouncing it well. Pink, and then we have Traceroute. Okay. Okay, so Pink and Traceroute, these are still part of network. This is still part of networking. So we have not left networking yet. This is part of networking. Now, what does the pink, when you ping a particular domain, or you ping a particular host computer, or you ping a particular IP address, what does it do? What the ping services tells you if the destination, okay? Let's say you want to communicate with a particular computer. Communication is between the source and destination, okay? And in between the source and the destination is the media, that's the medium through which the information is traveling. These are basic stuff you should already know, okay? And from our previous networking knowledge, I already told you how information travels through a network to get to its destination. That's why we studied all those basic stuff like what is a network. We studied what IP addresses do, what MAC addresses do, and what port does. Okay. So when we talk about ping services tells you if the destination is reachable. You understand? Like, it's just to check if this particular destination that you want to reach, is it reachable? Then the trace route reveals the exact, like the route, that's the route a packet takes to reach that destination. Okay, let's say you are sending a packet from one computer to another through a network. If you carry out the ping services, it will tell you if your system can communicate with that system. That's why the ping services check. Why Traceroute tells you if it tells you how your information, how your packet, whatever you're sending to that computer, will be able to travel from your computer, which is the destination, which is the source, to the other computer, which is the destination. Okay. So the ping services will tell you if you can reach a particular server, and Traceroute will show you how to get to that particular server. So without talking too much, let's try to check this out. Okay. Now, why is this important? First of all, this is important because in networking, at times, let's say you are in charge of a particular network, maybe in a particular organization, and you just came up one day and you discover that, okay, a particular computer can no longer communicate with the other computer, or maybe can no longer communicate to the server. Okay, so the first thing you are supposed to do as a computer or as the network engineer is to carry out these things, these ping services, to check if your computer is if that particular computer can communicate with the server, or if that particular computer can communicate with the other one, just to check how the communication is working, so that you will now know where the problem is coming from. Okay, so let's say so let's use Google again as our example. So let's say you want to check if your computer can be able to reach google.com. What the hell? What just happened? Please, 1 minute. I don't know what happened. I think my system locked me out. Okay, I believe you can still see my screen. Let me see if I can increase the font so that you can see it. Okay. To increase the font size, you click on Control Shift plus. Control Shift plus to increase the font, just like I did now. Okay. We're still going to come back to this interface. I will show you how it really functions. For now, let's just do this. So we have ping www.google.com. Okay. So what we're trying to check is if my computer, I'm typing this from my computer, my system, right? And if you are with your system, you can also do the same. So we're trying to check if our system can be able to reach google.com, this particular domain. Okay. So you press enter. So you can see it's reading. The first line is ping www. So it now gave us the IP address of the Google server where we are trying to reach, right? So now it's confirming to us that yes, it can reach Google. You can see the data is sending 64 byte from loss this, 64 byte from loss this. So this will continue until you interrupt it. And to interrupt, Control C. To interrupt this process, you press Control C. If not, it will continue running. Okay. To interrupt this process, you press Control C. Okay. To clear this information, just type clear. It will clear everything from your terminal. So we are back to where we started. So let's do that again. Ping www.google.com and press enter. So it will continue sending until you press Ctrl C to interrupt the process. So it will now stop sending. Okay. So let me clear this again. Let's see another domain. Let's say ping www.iss.org. So this is also working. So it tells you that this website is up and running, and it's giving you the type of information that the website is that are running, that the website is able to receive. Like you can see all this ICMP, the time it is taking for your computer to reach the that server. Okay. So now let's go to Traceroute. Let me clear this so that my screen will be clear. So let's go to Traceroute. I already explained to you what Traceroute does. Okay. So Traceroute, www.google.com, the same website. Now Traceroute is not like that ping services that we did. This one gives you a different information, right? So it tells you like the route that it takes, that your system is when you send information from your system, how it will follow before it gets to when you send information from your system, how it will follow before it gets to that particular system, okay, to the server of Google in this situation, because we're using Google in this particular situation. So let's try to analyze this information that came up here. All this information you're seeing here, right? So the first thing we're having here is traceroute to www.google.com, open bracket 216.58.223.228. Okay, so this is the IP address of the destination. The destination we are trying to reach is google.com, right? So it has, the first information it gave us is the IP address of google.com. I already told you that the computer does not really understand all this English. When you type something like this www.google.com, the computer does not really understand. So it has to convert this domain into an IP address for it to understand what you're really talking about. So the first thing it did was to get the IP address that is corresponding to this Google .com, which is the destination we're trying reach, right? So the next thing we're having here is the hops. Let me expand this a little bit. Okay, so the next thing we're having here is 30 hops. You can see just after that IP address, we're having 30 hops. 30 hops. Okay, 30 hops max. So that hops, that what they're referring to as hop here, these are the network devices. Okay, network devices, for example, things like router. When you send information from your own system, your system has its own network. Like your system is connected maybe to your phone. Your system is using your phone internet to browse, right? And your phone itself is also connected to another internet, maybe MTN tower somewhere. So these hopes, these 30 hopes, these are like different network devices that this information will pass through before it gets to Google server. So it will pass through, maybe from, in my own case, now I'm using a router. So it's going to pass through my router. It is an MTN router. So it will first, after entering my router, this router is communicating to maybe a nearby MTN tower. So it will first communicate to that tower. That tower will now communicate maybe with another tower, like that, until it gets to Google server. It will now also communicate with the network that Google server is using, because Google server is also will be running on a particular internet service provider. It gets to that internet service provider before it finally gets to the Google server, right? So in general, it has passed through 30 hops, maximum of 30 hops, which what they are referring to as 30 hops, these are different network devices that this packet will pass through before reaching the Google, before reaching the Google server where this IP address is located. Okay, so this is what Traceroute is doing. It's showing you how your information travels to get to that destination. So the next thing we have is this 60 byte 60-byte packet. Okay, so 60-byte packet is showing you the size of the ICMP control message. Okay, it's showing you the size of the ICMP. ICMP simply means Internet Control Message Protocol. So the ICMP 60-byte packet is showing you the ICMP, the size of the ICMP. Okay, ICMP is like a network protocol used by devices to communicate errors, right? So the ICMP helps you to know if there are any errors. You know, like when you, if for those of you that browse a lot, at times when in a particular website and maybe you are unable to reach that website, you see an error will pop up. This website is not reachable at the moment, or it will show you network error, just different kind of error. So this is the same thing, but in this case now we're having it on the command line interface instead of your normal graphical user interface where there will just an error will just pop up, right? So here we are dealing with command line interface. So they are telling you this 60-byte packet now went through. There was no error, like it went through. Okay, so 60-byte packet is showing the size of the ICMP. Like I already said, ICMP stands for Internet Control Message Protocol. Okay, and the ICMP is like it's a network protocol used by devices to communicate errors and operational information about data transmission. Okay, essentially acting as a way to diagnose network issues by sending error messages when packets cannot reach their destination. So ICMP will send you an error when a particular packet cannot reach its destination. Okay, but if you look at this, there was no error, which means the packet can actually reach that destination. That means Google's website is up and running. I just hope that we are following. Okay. So in a situation where the packet encounter a problem during transmission, this ICMP will give you the error report of what happened along the way. So after that 60-byte packet, the next thing we're having is this one. Okay, when they wrote one, then they gave a little bit of space, and the next thing they're writing is an IP address 192.168.244.2, and they still put the same IP address in the bracket. Okay, now that one indicates the first hop in the route. One indicate the first hop in the route. You know, I already told you what a hop is. Okay, that is the those are the hops are the network devices that the packet will pass through before getting to its destination. Okay, so this one indicates this hop in the that's the first hop in the route. Now, the IP address that follows immediately after that one represent the IP address of that first hop, the IP address of the first device that your packet encountered before getting to the final destination, which is 192.168.244.2. So this could be like, I think this should be like the IP address of my router, because that's the first hop that the packet is passing through before getting to its destination. Okay, so after this, the packet will pass through 29 or more other hops before it finally gets uh, the destination. So this IP address will be like the if you remember when we did packet tracer, this IP address could be like that gateway IP address, your router gateway. Okay, this could be like the default gateway IP address of your router. Um, I wish this was like a physical class 101, so that as we are saying all these things, maybe there could be a board where I also demonstrate some other things so that you understand better. But I believe you are following and you understand what is um, happening. Now, one of the things you observe IP address, if you followed our lectures, our networking lectures, where we talked about IP addressing, one of the things you observe from this IP address is that this is a local IP address. That means it belongs to a local network, right? Uh, so definitely this will be an IP address of a network within my own network, not outside of my own network. You know, we did public IP addresses and we did private IP addresses. I believe you know the range for each of those IP addresses. So studying this particular IP address, you observe that this is um, a local IP address. So after the IP address, we have there's a value there. That value that you're seeing 3.121 ms. Then we have 1.599 ms. We have 0.698 ms. I believe you can all read all this stuff. Please, if you can see all these things I'm talking about, please confirm so that I would know we are together. Let it not be that I'm just blabbing alone. uh, okay, okay. That's fine. Let's carry on. I know some of this stuff might sound like jargon, but by the time you take your time to look, maybe study, go through this, you can watch this video over and over again. You get some clarity. I also drop some books that materials that you can read. I'll drop some materials that you can also read. Okay, so we are on this 3.1.2 3.121 ms, 1.599 ms, and 0.698 ms. Okay, now this indicates like the round. That's like the round trip. This is this in Traceroute. This is called round trip timer. Okay, round trip timer, and it is in milliseconds. So this is just like telling you the time that the packet that it took for your own network. That's my, in this case now, my own network, because I ran this on my system. Okay, so this is indicating the time that it took the device, that's my device, to send information to the destination. That's the in this case we are talking about Google, and back. Okay, so this, like I said, this is usually is called round trip timer, or you, in most cases, you might just see RTT, round trip timer. Okay, this indicates in milliseconds that it took the device to and back multiple times as shown, because so this why you are having time 1, time 2, and time 3 is because what we are trying to do here, this trace route, what it tries to do is to check the route that your device will take to communicate with this particular domain. So why you're having multiple times is because the packet is usually sent multiple times in case of error. So by default, the packet is sent multiple times just to be sure. Maybe if the first one did not go, the second one will go. If the second one did not go, the third one will go. Okay, so if you look at it, you see their time is different. Sorry, let me log in again. Okay, so if you look at it, you see their timing is different. The first time it took more time because at that point it was still trying to find the route. Then the second one, it took lesser time. Then the third one, it took even lesser time. Okay, so like that. So the by default the packet is sent 3 times just to confirm um, that this destination is reachable, and also to confirm the best possible route that it can take to get to that destination as fast as possible, which is what we studied in routing, and that is what routing and switching is all about. Okay, so the next thing we are looking at, let me clear this. I just hope we are following. What is the time? This is 9:13. Okay, so when it's like, maybe let's do this. I just hope we'll be able to finish. Anyway, if we can't finish it today, we'll continue tomorrow. So let me clear this. So the next thing we're looking at is what we call um, um, what we call if config. Okay, if config. Now in Windows, this is known as IP config. So that you don't confuse it. For most of us, maybe we already have an idea of what this is. In Windows, it is IP config. In Kali, it is if config. If config. Let me drop that in. Let me drop that in the chat so that you can see. If config. Everything small letter, please. If config. Okay. So now, if config, what if config does is it tells you the interface configuration. Okay, it tells you the configuration of your interface. That's when I'm talking about interface, I'm talking about your network interface, because your system is an interface on its own. Okay, so it tells you the configuration of your interface. So let's quickly run this. If config. Okay, so this is just what you type. If config. If, like I said, if it's Windows, it is IP config, not if config. So just type this, and then you press enter. So you'll be seeing a lot of jargons here. For now, those things are jargon because you don't really know what it is, right? Okay, so by the time you type that if config, this is what you'll be seeing. Let me put this full screen so that you can see it better. Okay, so let's analyze this line by line. Okay, the first line we're seeing here is this ETO, or let's say ETH0. ETH0. Okay, so that's the first line we are seeing there. Now that ETH simply means Ethernet. That means the type of network interface I am using currently. I'm using Ethernet. Okay, so my system is connected via an Ethernet. I believe we did this in our previous classes. I told you what Ethernet is. We talked about Ethernet cables and all of that. So that ETH0 is telling you that my system interface is using an Ethernet network interface. Okay, that ETH0 is kind of like the flag. Okay, and it has given you the flag number 4163. Then the next thing you are seeing after that flag equal to 4163 less than, you are seeing that up. Now that up means my network is up and running. That interface, it means my interface is up and running without any issues. Okay, then the next thing we're having here is the broadcast. Please mind you, we're still on that line 1, that first line. And I believe as I'm talking, you are seeing what I'm talking about. So the next thing is this broadcast. That broadcast simply means the interface support sending broadcast messages. That means it can send messages to all devices that are connected on this my network. That means my interface can send a broadcast message to all devices that are connected to this my network, this my local network, right? So I can send a broadcast message. So that's one. Then we still have running, also indicating that my interface is operational, that the interface is up and running. Then we have multicast. Multicast means it supports multicast communications. That means it supports multicast communication. This is used, multicast is used mostly in video streaming. You understand? Like now I'm kind of, let's say I'm kind of like streaming right now, and all of you are able, from your various systems, you are able to watch my screen, right? That means this interface is support multicast. Uh, that means this interface supports multicast communication. Okay. Then the next thing we're having is MTU 500. MTU 500. Okay. That MTU stands for maximum transmission unit. That MTU stands for maximum transmission unit. I'll come again. That MTU stands for maximum transmission unit. Okay. And what does this represent? This represents the largest packet size. That means the largest packet that my network or my interface can transmit at a time. You understand? That 1,500 you're seeing is in byte. Okay, so that means the maximum packet of data that my network, my interface can transmit at a time is 1,500 byte. Okay, and this 1,500 is mostly like a standard for every um Ethernet. Okay, any network that is using Ethernet, this is the standard for the standard MTU. That's maximum transmission unit. Okay, so this is 9:22. So please, I will stop here. Tomorrow we'll continue analyzing this IP config. Then, if there's still more time, then we'll look at other things. Okay, and in fact, there's just a lot to learn. That's why we are taking this for 6 months. So just relax. There's still a lot that we are going to be looking at. These are just like the foundational stuff that you need to know. Okay, and don't take any of these steps for granted, because you need all of this as you move forward. Not that when you get somewhere and we are mentioning all these things, you begin to say, what is this? It should be something you already knew, right? That's why I'm taking my time to explain all of this. As we proceed, you are going to see why all of this is actually important. Okay, these little things are the reason a hacker is able to succeed, hack a system and steal whatever he needs to steal, or destroy whatever he needs to destroy. So let's stop here for tonight. Tomorrow